Consider the two planes x plus 3y minus 2z equals 7 and 2x plus y minus 3z equals 0 in R3. Which of the following sets is the intersection of these planes? And we're given 3 possible sets here. Okay, so usually I like to work things out directly. I kind of here's my thinking here. Normally, I don't want to guess and check or anything like that. I would like to just compute what the intersection of these planes is, and then figure out and find which of the options corresponds to that. I think I'll probably still do something more or less, but the thing we'll have to watch out for is that first, we know that when we have two planes in R3, if they intersect, then they're going to intersect in a straight line, and there are multiple different ways of representing a straight line set in R3. So even though I might compute this, the answer I get might not be exactly what's given. Okay, so another thing to realize right away, the two planes, let me write them down here. That's one plane, and I also have 2x plus y minus 3z is equal to 0. The coefficients, if we think of the coefficients as three-dimensional vectors, they define the normal vector to the plane, and those two vectors are not scalar multiples of each other here. So these planes are not parallel, which means they definitely intersect somewhere. So the answer is not A, the empty set. In addition, when two planes intersect in three-dimensional space, they intersect in a straight line. So option B, which gives a single point, cannot be the correct option. And finally, option E defines a set which is another plane in the space. And so that can't possibly be the answer either. So we know that it's C and D, either option C or D. So what I'm going to do here in order to solve this is I'm simply going to eliminate one of the variables. And I'm cheating a little bit by looking at the way they express the answers for both options C and D. And I see that it looks like the variable x is the one that's considered their free variable. So I wonder if I should do this by eliminating x. I'm going to go like this. No, hold on, let's just do what I think is most straightforward. I'm going to eliminate the variable x. Minus 2z is equal, minus 4z is equal to 14. And I have 2x plus y minus 3z is equal to 0. So if I subtract the bottom line from the top line, I have 5y minus z is equal to 14. So z is equal to 5y minus 14. This is probably not going to end up with one of the expressions that's given as an option. Now, you know what? Let's eliminate something other than x. Again, just the way that the options are written there, thinking of things in terms of x might be a little bit easier. Okay, so I'm going to take the first expression, x plus 3y minus 2z is equal to 7. 2x plus y minus 3z equals 0. I'm going to multiply the bottom line by 3. 6x plus 3y minus 9z equals 0. And let's take the top line minus the bottom line. Negative 5x plus 7z is equal to 7. And I'll write this as 7z is equal to 7 plus 5x. So z is equal to 1 plus 5 over 7x. Yeah, so it's looking like the answer is going to be option D. So now what I want to do is I want to solve for y in terms of x. If I go back to 2x plus y minus 3z is equal to 0, this gives 2x plus y minus 3 times 1 plus 5 over 7x is equal to 0. So I have 2x plus y minus 3 minus 15 over 7x is equal to 0. So y is equal to 3 plus 15 over 7x minus 2x plus 15 over 7x minus 14 over 7x. So y is equal to 3 plus 1 over 7x. And so what they've done is they've introduced a free variable t, and let x be equal to 7t, then y is equal to 3 plus t, and z is equal to 1 plus 5t. And this is the parameterization that's given in option D. There's more than one way to do this, right? Because I or they have arbitrarily said that the free variable will be x. Well, the free variable will be x divided by 7, essentially, because x over 7 happens to appear in a few places. So we just set that equal to t and write everything else in that way. But I just as easily, if I'd done it, if I continued this way, with this expression, maybe I should allow y to be my free variable, and then I would just get a different parameterization of the same line. So there's other ways that you could approach this. You know, for example, one thing to do would be just take all the expressions they have and verify whether they lie on both planes or not. So we eliminated options A, B, and E immediately. But if you take option C and the parameterization they have of x, y, and z, and substitute that into both of the original planes, you should find that on at least one of them you do not get that the relation holds, which shows that that parameterization does not represent the intersection of the two planes. Yeah, pretty straightforward question overall. You know, I did it a more roundabout way than what I would typically do if I were actually writing this exam, but it was a more sort of direct way if it wasn't a multiple choice exam, but if it was just a straightforward computation they asked for. Thanks for watching.